factor label method for converting units. And a lot of times people call this dimensional analysis. So it's in your textbook on page 23. And we're going to do some practice today. So when do we use this? Well, instead of just moving the decimal point, we would use this when we want to convert units that there's just more than one basic unit. So what I mean is we're not going from centimeters to meters. We have units that are a little bit more complicated. For example, if we have 5 kilometers per hour and we want to convert that to meters per second. So there's a few basic things you need to remember. Number one, when you write your unit you're starting with, always make sure that you write a blank fraction afterwards. And I'll demonstrate how to do this. Whatever's in the numerator, put the same thing in the denominator. Okay? And then cancel the units top and bottom. So for example, I start off with 5 kilometers per hour. I'm then going to do a blank parentheses. And if kilometers is the numerator, I put that in the denominator. What do I want to end up with? I want to end up with meters. So now I have to think of the conversion between kilometers and meters, and there's 1,000 meters in a kilometer. So then these are going to cancel. Then I have hours here, and I want to end up with seconds. The more you write down on paper, the less likely you are to make a mistake. So if hours is here in the numerator, I'm going to put it in the denominator. And off the top of my head, I know there's 60 minutes in an hour, so now these cancel. Now I have meters per minute, but I want meters per second. So if minutes is in the denominator, I put it in the numerator, so they cancel, and there's 60 seconds in a minute. So I end up with meters per second, which is what I want. And that's it. Now we're going to work some of the homework problems together. So here's our homework. And let's start with number 4. So number 4 says, how many seconds are there in a year? So I'm starting off with 1 year. Now, because that's just a number, this is over 1. So you're always going to make your fraction as a horizontal line, and you can put it over 1 because that'll help you with the conversion process. Now, I want to know seconds, so I'm going to put seconds all the way on the end because that's what I want to end up with. Where do I start? I start here. So first I write my blank. Because year is in the numerator, I put year in the denominator. That's how I cancel it. Now, I don't know how many seconds are in a year. The only thing that I know off the top of my head is days. So there's 365 days in 1 year. So now my years cancel. So now I have days, but I don't want days, I want seconds. So to get rid of days in the numerator, I put in the denominator. And the only thing I know is there's 24 hours in 1 day. So now my days cancel. But I have hours, but I want seconds. If hours is in the numerator, I put it in the denominator. And what I know off the top of my head is I know that there is 60 minutes in 1 hour. So now my hours cancel. Now I have minutes, and I want seconds. If minutes is in the numerator, I put it in the denominator. And I want to go from minutes to seconds, and I know that there's 60 seconds in 1 minute. So now these cancel. So I end up with seconds. Is that my correct unit? Yes. What about my number? Well, what you do is you multiply everything in the numerator. 1 times 365 times 24 times 60 times 60. And you divide by everything in the denominator, which in this case is just 1. And my answer comes out to be 31,536,000. That's my answer. All right, let's do number 7. So number 7 is the density of water is 1 gram per centimeter cubed. What is this value in kilograms per cubic meter? So I start off with 1 gram per centimeter cubed, and I want to end up with kilograms per meter cubed. So I always put at the end what I want to end up with because it kind of tells me what to do. So let's start with the top. I have grams in the numerator. To get rid of grams in the numerator, I put it in the denominator. And what do I want to go to? I want to go to kilograms. Now, when I learned this a long time ago, I already know there's 1,000 grams in a kilogram, and sometimes in chemistry you put the prefix, and you can do that. It's also correct. And this is also on our handout that we got that first has the two types of conversions. So now this cancels with that. Now this is a centimeter cubed. So you can cube the conversion, but a lot of people make a mistake. So just to make sure we don't make a mistake, a centimeter cubed is a centimeter times a centimeter times a centimeter. And the reason I do that is I want to end up with meter cubed. So if centimeters is in the denominator, I'm going to put in the numerator. And I know there's 100 centimeters in a meter. And now this centimeter cancels with just one of those. I know there's 100 centimeters in a meter. So now this cancels with that. And I know that there's 100 centimeters in a meter, and this cancels with that. And what am I left with? A meter times a meter times a meter is a meter cubed. And now I have my kilogram. So my final answer, unit-wise, is correct. And when I multiply it out, I get 1,000 kilograms per meter cubed. Let's go back and do number 5. Number 5 says the speed limit on a highway in Lower Slobovia was given as 150,000 furlongs per fortnight. What you're going to do first is when I write my number, 150,000 furlongs per fortnight, I'm going to make sure that the division sign looks like this. Because remember, we're always doing units as fractions. Now I'm going to put this over 1 so I don't make a mistake with the number. So how do I know where to begin? It doesn't matter. Let's start with the top. It says furlong. So if I want to get rid of something in the numerator, I put it in the denominator. Well, what do I know about a furlong? Well, if I look at the sheet, it says that 1 furlong is 1/8 of a mile. So I'm going to write it just as I read it. 1 furlong is 1/8 of a mile. So now I see that this furlong cancels with this furlong. So now I have miles per fortnight, but actually what I want is I want miles per hour. So I remember I want to put at the end what I want to end up with. I already have my miles here, so I'm good with the top. So now I can start looking at the bottom. So I have fortnight in the denominator. So I put fortnight in the numerator. And I want to go from fortnight to hours. Well, it doesn't say fortnight per hours. It says fortnight in days. So what it tells me is 1 fortnight is 14 days. So this fortnight in the denominator cancels with this fortnight in the numerator. So now I have miles per day, but I want miles per hour. So what I do is, if days is in the denominator, I put it in the numerator. And I want to go from days to hours, and I know that there are 24 hours in one day. So now this day cancels with that, and I end up with miles per hour. So I know I'm going to have the right unit. Well, what do I do about my number? So it's going to be 150,000 times 1/8 times 1 times 1, all divided by 1 times 1 times 14 times 24, and then I get my answer, which is 55.8, which in physics, our answer should always be realistic to what we know. And that's it. That's 3 of actually the harder problems.